Good morning. Thank you for having me. I know it's kind of last minute. A colleague of mine who runs the Northeast was supposed to do this presentation, but I was glad to fill in for him. As Mike said, I'm the Mid-Atlantic Regional Sales Manager with Eaton. I actually come from the Cooper side of the business before Eaton had acquired us. I've been doing this for about 13 years, involved in mass notification and life safety, wearing a number of hats through the years that I've been here, application engineering support, and now up through sales. And with this whole acquisition, I came in, and with this Eaton merger, I run the Mid-Atlantic area. You see I cover 6 states in my area in the Mid-Atlantic: Pennsylvania, DC, Delaware, Virginia, Maryland, and West Virginia. So maybe I've run into you before on the phone. Like I said, I've been doing this a while. I'm aware of a lot of the ADI process. We're talking about intelligibility and efficiency and designing with, talking about audibility and intelligibility here. This presentation is quite long. There's quite a bit of code. I'm going to kind of run through it and try to stay within an hour. It'd be probably easier to do a Q&A and answer more questions for you. But we may bounce around a little bit, and we're going to run through the code part somewhat quickly, but let's just kind of get right into it. Again, this is a registered class, so normally when we give this, we work and partner up with this RCEP, which is an accreditation and a certification program. And for the time being, I'm gonna kind of just run right through this part. Let's talk about the agenda, what we're gonna do here today. We'll talk briefly. I'm gonna throw up a slide for our U.S. sales coverage map, show some of the faces around the country, some of the people you guys may know already. We have a good presence across the country. Most of the team has been here for a while. Talk a little bit about the history of mass notification, its inception, where it came from, up to where we are now. A little bit about threats in the environment today and what we face, why we have mass notification, why it's important. Really common sense when you think about the threats that we face, but we'll talk a little bit about that. I'll touch briefly on the target markets and drivers, some of the numbers and the money that's involved, and obviously it's big business. And then we'll get into the intelligibility, the audibility part of the presentation, what everybody's here for anyway. What are the differences between intelligibility and audibility? Some information you guys are probably looking for now. You're seeing these come out in specs. What does it mean to me? Where do I go with it? And we could talk a little bit about that, understanding, what the differences are. Then we come to this portion of the slide, this deck, where it's just all NIST and NFPA standards and guidelines, which are right out of the book. So depending on time, I'll keep an eye out here, but depending on time, we're going to probably run through this. This is all directly out of the code book, and it's required for the class when we give it. I didn't pull it out. I'm leaving it in here. And then finally, we'll talk a little bit about our LED technology, our efficiency, some of our products, where we are and where we were with LED, and how it relates a little bit to intelligibility, because we've been involved in it for many, many years, with our product line. We won't stand up on the soapbox here, but Cooper was all about intelligibility at an early stage, where we started switching over to high fidelity devices, and we carried that through with our LED line, and we'll talk a little bit about that as well. So real quickly, this is a territory map of the country. It was from January. You can kind of see salespeople that you may recognize and names. This information, some of it has actually changed with management on the right-hand corner. But when this is over, we could certainly provide information, territory-wide on who the contacts are, who the managers are, and so forth. And as you can see, I'm over here in the blue, covering the Mid-Atlantic region. But we could send something out in an email to everybody who's on the phone right now if they need to know who to talk to. And I'll tell you right now, that's honestly, in my opinion, is the number one thing that I would do. And what I recommend to people is to call your sales managers, call your contacts within our organization to help you when it comes to intelligibility and audibility. It happens, this is constant for me, where they're calling up and saying, where do I get this? How do I do that? And we can provide a great deal of information as a manufacturer, especially when using our product, DLL files and things that could help when they're running tests. So keep that in mind too. It's a good starting point to just pick up the phone or send an email to a rep, one of our guys. Be a very big help. So again, this is a course that has objectives. This is a course that was given for credits. Obviously, we're here to understand mass notification, understand some design considerations of intelligibility. We're going to talk about audibility, and I think you know why you're here. The evolution of mass notification. So this is a few slides, but not everybody understands where it came from. I started back in 1996 with the Cobalt Tower attack in Saudi Arabia, and it kind of has progressed all the way from 1996 to where we are today. And it's gone through a number of changes with spec. But some of the things, I just like to go through these slides quickly just to point out a few things, because it all really is entrenched in military. It's where it started. Everything came from anti-terrorism and standards developed by the Air Force back in 1999, where they created a UFC criteria for these attacks and started putting guidelines together based upon terrorism acts. And that's where it started. So the United Facilities criteria was in the late 90s, early into the 2000s, where they started Department of Defense, DOD, anti-terrorism standards. And this code is still used today. It was actually used to derive all other code related to voice and mass notification, which also was brought in from the military world into the commercial world. And you'll see that in the slides. So as you progress up through the military at UFC, it started working in parallel or in combining with the fire standards. It was just likely that that's where it was going to go in a commercial sense. So, the Air Force worked with NFPA to develop standards, and then you got the NFPA started getting involved and adding annexes. One of the early ones with me was I was very familiar with, and UFC working on the military side with this UFC criteria back in the 2003, 2005 area. NFPA then around that same time gave an annex on the commercial world where they start putting data details in there. None of it was code driven. Everything was stuck in here as reference material or suggestions of where you need to go. Eventually, NFPA started moving forward. Voice became very popular. Intelligibility with voice became popular. Exterior became popular. All this was added into the annexes of that NFPA guidelines when we're talking commercially. And finally, in 2010, they took it and gave a chapter for mass notification for the private sector, the commercial world. It was the first time that you saw anything where we got a chapter. Again, recommendations and suggestions on how it has to be. That's where mass notification really started in the commercial world. And it was in my world where it became very important in the fire world when you start to talk about interior voice. So just a brief history of where it came from and took to this date. And again, there are some other codes and things we'll start bringing up and talking about where other agencies came in. It's not just the UFC or NFPA. It's NIST. There's some stuff I know in the building code, IBC manual. There's stuff in FEMA. Lot of code references when it comes to voice systems and mass notification. What is mass notification, right? It's a method, a voice method primarily, of providing real-time information to people regarding an incident. This is exactly how it's defined in the UFC. We're talking about bringing voice communications along with a visible signal and text or graphics, however it is, to alert the media, as many people as you can in the most efficient method. That's really where we are with it. And again, this is coming. You'll see that on these slides, a lot of this information comes directly from the code book. And there might be a lot of you out there that know this code even better than I do. Back to the evolution, you know, where it comes from, where we just started, coming up a little bit closer in time frame, 2010 up to 2020. UL 2572 became a big part of NFPA, a chapter where there was a specific communication method and process for internal voice. UL 2572 was a NFPA code for interior voice. Again, through the derivative of all of this mass notification coming up through. DoD redefined their code requirements based upon emergency notification in 2014. NFPA, which obviously changes, you know, NFPA 72, 2013, goes up to 2016, 2018. And all these codes are driven directly by, you know, AHJs, and all states have different adaptations of what they currently are using. But you could see the development all through the years where NFPA has changed from, you know, 2013 edition, it's still chapter 24. 2016, which in my neck of the woods, a few states are still using, again, still in chapter 24, talking about, just basically talking about all the changes from where it went, and hey, you have to have voice, all the way up through network voice or how it can be used. And it all has a little bit to do with the intelligibility. The International Facilities Code, IFC, in 2018 has an MNS chapter that came out a couple of years ago. The latest rev of NFPA 72 2019, talking about addressable notifications, adding CO, again, just more and more updates to NFPA, which is pretty common in this industry. But just to point out, if you look back at the earlier slide, I'm not going to go back, the audio piece of this, intelligibility, started out very early in chapter 24. It was one of the first pieces. The purpose. In my opinion, you know, common sense. NFPA defines the purpose of emergency system right here. You know, it's the protection of a life in an emergency situation, to communicate the information about emergencies, not just limited to fire or human events, but all events, anything dangerous, weather alerts. And let's, you know, briefly talk about some of those. A mass notification system, in a world when we talk about emergency, you know, this word, MNS, mass notification, emergency communications, all relating to voice. With voice, there always is going to be a visible signals, text, things that the AHJ, for hard of hearing or the impaired, need to also be informed. So it's always an audio-visual system. This, again, is straight out of NFPA. The systems can be wired, wireless, or a combination of both. In our world, when we talk about a mass notification system or a voice system, and I get this all the time, you know, how do I bring voice internally? How do I get voice to my buildings? In our world, and the people that are probably listening to me right now, it's more than just putting a speaker system in. Mass notification and emergency communications are defined primarily that these systems are very similar to fire systems in the sense that they are supervised. The system needs to constantly be checking itself so that when an event happens, it works, meaning backup battery systems, and it operates on battery rather than straight AC power or along those lines. But that's when we talk about it in you know, from my conversations with people that I have regularly, what an MNS system or emergency communication system is. Threats, pretty common, you know, it's really common sense here. Natural disasters, weather anomalies, industrial disasters, hazmat, public health events, sometimes power outages and contamination situations. You know, the traditional threats, non-traditional, they're calling it terrorism, not really a traditional, I don't know, I would, you know, it's become pretty common nowadays. Disorder, general life safety issues of an evacuation, a shelter in place in schools, in industry, in the commercial world. Life safety has become a big thing. It's a buzzword with facilities managers all around the country, setting up drills, muster points. It's a big thing in the commercial world with building owners and companies protecting their employees. I have many customers and users we're talking about that have things, you know, processes in place. They run drills to not just the schools where it was very, very big, It's everywhere. They run muster drills once a quarter. They have voice systems in place where they'll run a drill. They'll evacuate. They'll have interior and exterior evacuation plans. It's very, very big. So the need is for an intelligible system is critical. You want to have intelligible voice that people could hear. How are you going to communicate with them in a wide area? Because of the threats, you want to have systems in place that you could hear that are clear, loud, intelligible, as well as audible. And that's what we're kind of here to discuss, because they're really two different plans. Interior as well as exterior. They're handled they're handled in a similar way when it comes to intelligibility and audio. The compliances for mass notification. These are just some of them. I mentioned you earlier while we were talking about the development through the years, starting back in the 90s with the UFC, but these are just, some of the codes, the books, the compliances you're going to hear about when it comes to intelligibility. I'm not an intelligibility expert. I don't test for it myself. I've just been around it for a long time, and these come up all the time. You'll always hear about DOD. You'll always hear about UFC. NFPA 24 is quoted constantly in our world on the fire side of things. But some of the other acts that, are regulatory are the Higher Education Opportunity Act, the Clary Act, which is something that came out years ago. This was a crime act that all of a sudden encompassed mass notification as well. Some of the HEOA thing and the Clary Act, they all became very, very popular after some of the commercial shootings and things that happened in campuses. You talk about OSHA. I mentioned FEMA earlier, but OSHA also has requirements with 1910, talking about employee alarm systems. FEMA has regulations. And of course, the ADA, which are the Disabilities Act organization, all looking for compliances when it comes to, or have special requirements that they're talking about for mass notification. Not super important in what we're talking about, but this is just the vertical markets and numerous opportunities where voice is required. In my days in running my particular area and talking to some of our colleagues, commercial's very, very big right now. Education, you would think, is the biggest sector, the biggest vertical market that for voice and for emergency communications, but it's not. Commercial, industrial, oil and gas, petrochem, healthcare, government buildings, all very big. The military, this is one of the largest sectors. It was very prominent during the wartime, but the military is always involved in the latest, the greatest, and notification systems. They're constantly evolving with it. They're one of the sectors that still to this day will go with two disparate systems when it comes to fire as well as voice, emergency communications, and it's spelled out in their spec. Utilities, I've worked with utilities, transportation companies, tunnel authorities, all looking for voice. So back in 10 years ago, it was primarily higher ed and education. I have a lot of questions, a lot of calls from engineering firms that are specifying when they're doing remodels of smaller school systems like the K-12 environment, where the schools are all in a giant campus environment. That's also a pretty big vertical when it comes to exterior interior voice. Not super important. I'm going to rush through this, but you could just see by the chart, where the money lies and how things are increasing when it comes to services and maintenance and where the forecast for mass notification is going. I don't think it's, super urgent. In the essence of time, we're just going to kind of go through this, but it's going up. Like I said here, you can look and you can see that the commercial world, education is still right behind it, but the other verticals, really, and ADI is, all of our partners, constant calls in all these different vertical markets with different requirements. And not only requirements, it's the companies wanting to be involved, wanting to protect their employees, wanting to have systems in place for these emergencies, and it's a combination, because the code book, and this is in a code class, but the code book calls for a system that's multi-layered. And multi-layered is audible systems for the interior and exterior of a facility. And that's why these verticals are popping up, like the healthcare, oil and gas, petrochem, outside audio. Very important. They want to be able to be prepared if there's a weather incident, something where they can prepare their employees. And it's all big. Facility people, most markets, they all have some group of people that get together to talk about the protection and how they're going to handle all these different these cases. Just again, percentages by vertical market and the increase through the years up through 2018. Drivers, pretty straightforward. Why we need it. The market drivers are really, in my opinion, it's common sense. They'll be, the big ones are the incidents, safety for the personnel. I've mentioned this several times already as I'm just talking. Preparedness, regulatory compliance is very big. A lot of times these things are coming out on specs. And when we're talking about audibility and intelligibility, that's what we're talking about, a regulatory compliance. That's pretty much where we hear it. I'll talk this all the time. Somebody's going to call me and say, hey, I want to put speakers in here. How do I do it? I'm going to bring it up. This is how we do it. And you're going to want to use high fidelity speakers because we're talking about intelligibility, even if it's not required. It just makes sense to use the best speaker, the clearest, the highest frequency response, the cleanest sound. Just makes sense. So, okay, 25 minutes in. Let's talk a little bit about intelligibility versus audibility. I don't like to read all from slides, but some of this, it's really the way you have to go. But there are differences between intelligibility and audibility. They are not the same. Just like you're talking about, I'm talking to you right now, and some of the sayings that you may have heard loud and clear, any military people, 5x5, they're talking about the audible and the intelligible piece of what we're listening to. They are not the same. So it's important to know that. When you're talking about audibility, let's talk about how it's defined. dB or dBA is the state of how it's measured. Calculations in the fire world are very simple and straightforward. They look for a dB or a level of noise 15 decibels over ambient noise that's currently in the facility. So now we're talking about audibility, meaning we have to have the sound above a certain range when it comes to the audible level. Mathematically, it gets a little complex in talking about why and the loss of the dB as you go out in distance from the source. But as a rule of thumb, it's the inverse square law. At 100 dB at 10 feet, it keeps losing 6 dB as you go out. There's an actual formula for that. I won't get into that. Oh, listen to that. My watch is talking to me. Measurable. How do you measure audibility? You use equipment, sound level meters. A lot of guys have these in their cars. They're going out to a job. They push the button, see what the level of ambient noise is, and they know that where they need to be when they're designing for audibility. Great question I get all the time when it comes to audibility or intelligibility is, where do I get this measured? And there are specific companies out there that do this. And sometimes they're mentioned in the scope. Sometimes the integrator does it as part of their part in the overall project. But there is equipment and testing and classes and everything when it comes to. They mentioned here Goldline. Goldline is a piece of test equipment that measures sound level. This is just a definition of intelligibility, which is different. It's the measurable aspect of the signal, of the voice. It's expressed in a percentage. Its method of testing is completely different. There'll be an example in here. This is the standard, the UFC standard that talks about the latest standard when it comes to intelligibility, which has all been used in here. I like this slide because we mentioned this thing called EVAC. When we talk about intelligibility, and I know we're talking a lot of numbers and dates and codes. A couple of things I'd point out to people when we're talking about intelligibility is sound models and how to do it. The great thing to take from this slide is that program right there that says EVAC. EVAC is software that we use internally in our manufacturing plant, when you call and talk to our customer service technicians, to actually put together sound models for intelligibility and audibility. It's a great application. It has an interior and an exterior piece, but with our products, we have DLL files. We could import people's designs, and our integrators do this as well. And this is really where I go with intelligibility when I'm talking about it, just straight up. It's a design. You put in your design, you put in your measurements, your prints, and then you could lay out speakers based upon the criteria you're looking for, whatever's in the spec. I need this above ambient. I need this. This is what I need in dB, and this thing lays it all out for you. And our guys are actually really helpful when putting these together. These services are utilized all the time with our customers. When we talk about intelligibility, it's different than the volume or the audibility. Your audibility is going to be that volume over this. Intelligibility is different. Intelligibility has different testing equipment. It's very sophisticated. It's very dependent upon acoustics. It requires this modeling software and this equipment. It requires more knowledge of sound transmission. And that's why the software comes into play with this. Everything affects intelligibility. Exterior, when we're talking about exterior audibility and intelligibility specifically, the temperature, the weather conditions, all the trees, the topography of the location, all are going to affect intelligibility. The same goes for interior intelligibility. And this is where that sound modeling software comes in again. The finish of the room, the ceiling, the heights, what's on the windows, changing, the rugs, the floor type, furniture, all will have a huge effect on intelligibility. A lot of times, and again, we do a little Q&A here, just sharing some information with you. When a spec comes out for a fire job or a mass notification interior system, and it's designed where now you get in play with an audio engineering company that runs the tests, and you put together a design and the drawings get stamped, it gets very, very complicated. Obviously, the system needs to be put in place. The fire system needs to be tested. It needs to be blessed before there's going to be a certificate of CO for the project. Very, very challenging based upon the AHJ and who's going to be approving this in that sector, in the area of the country, because they could really hold you to the standard. And how are you supposed to test the building? You got to get the furniture in, the desks. It's very, very complicated, and it's very important that if the spec is called out for, that you work with somebody that really knows what they're doing, especially with timelines and the project management and the whole thing. I could tell you, how I handle it in, 10 minutes. We're doing okay on time. Yeah. How I handle intelligibility and audibility. It's basically, I think it's a slide in here. Intelligibility is more speakers. That's the bottom line. Lower taps and more speakers. If you got a room that you'd normally be putting one in, if it needs to be designed for intelligibility, you're going to be putting 4 to 5 in, and the taps are going to be much lower. And I'm fairly certain, I haven't given this presentation in quite some time, but fairly certain it's a slide in here. Intelligibility tests. There are two different methods, the CIS method and the STI, the Speech Transmission Index, is a method or a standard test for intelligibility, as well as the Common Intelligibility Scale, or the CIS. This shows that these are just two different tests. They're typically called out in the spec that, it has to meet a 0.8 CIS on the CIS intelligibility, but it's based upon balanced words, like they're saying here, and this MRT, this modified rhyme test, all part of this articulation index and this speech, this STI and this CIS test kit. They coincide with each other. So they're showing, on this picture, they're showing a 0.68 STI. Usually they'll show both the CIS and the STI, and they'll most likely be called out in the spec. Just intelligibility measurement standards and how they're doing it. And they're talking about NFPA. So there's going to be guidelines Again, stated back to the military. The military was doing intelligibility tests long before this started becoming very popular, especially in an exterior environment. The military would always call for a minimum of 0.7 to 0.8 on an exterior audio job, meaning that this test has to be put out in the field while they test the system, and this transmission test better come up with the minimum criteria that needs to be met. And they're calling for the DoD facilities right here in this slide, showing you where they are. This is pretty straightforward and pretty standard across the board. Here's the slide. So designing the general rule of thumb. I mean, that's my go-to when people ask me about, hey, what do you do with intelligibility? Well, you just put in a lot more speakers. You're going to use good speakers, and you're going to use a lot of them. You're going to drop the taps. Something that could be a watt, you're going to drop down to perhaps an eighth of a watt, and put in 5 of them. So this is just a good rule of thumb, and you can see from this slide, it could be as high as 8 times the speaker that would be in a room to get the intelligibility that you need, that these tests have to provide. And the way to do it, it's done by design. Somebody is going to use modeling software with the speakers that you're using, and they're going to lay them out. And that's the first thing that has to be done before you run all your circuits and how many amps you need and the power supplies and what you're doing. Somebody's going to run these models, and then it's going to be tested. And that's the part in the field where we're talking about the taps may change. The speakers need to be in phase. The ceiling height has to be discussed. It's all part of it. Frequency response. I said earlier, hey, I use a lot of speakers and I tap them low, and I'd use a good speaker. Very important, the frequency response of the speaker. The normal fire speaker has changed over the years. Our speaker products, for example, even before the acquisition and the change of our products in Eaton, we were already moving to more intelligent speakers, a broader frequency response, something that goes from a much wider range to be able to capture the speaking voice, because that's really what it's all about. So the broader the frequency response of the speaker, the cleaner that sound is. And of course, the frequency response of a speaker, if there's any audio files out there, is usually rated. It's going to be, down lower. The lower number is going to be closer to the DC area, up to the higher frequencies. But in this slide, they're talking about generally the frequency response of the fire alarm system. The speakers are typically 400 to 4,000 cycles. Commercial sound systems, 125 hertz, pretty low, up to 12,000 cycles for when you're just, talking about music, not just voice, but musical systems. Pro systems, here's a typical frequency response. But very important, because, the human's ears are related to the frequency response of that audio pattern, all having to do with its intelligibility. So the frequency response of speakers are critical. The wider the frequency response, the better it's going to reproduce the frequencies of that signal. Some of them are required. We're talking about intelligibility right now of the speaker. Some of the speakers would need to be not only registered or certified or compliant, for specific applications, but a speaker needs to be compliant with that frequency response to be able to reproduce the sound. Like something that's in the fire world that's changed in the last few years was the low frequency sounder, right? That's a code that has changed a few years back, where it's a lower frequency sound for sleeping rooms. I don't have to get into it, but that frequency response needs to be handled by a speaker, either a product that can handle that completely, that tone, the frequency of the low frequency, or a speaker that can handle it, or something that can generate the low frequency tone, and that the speaker can play it properly. So frequency response is important. When we talk frequency response, you're talking about the sound of the letters. If the range isn't wide enough, things like they say in this slide here, the S in sailing or the F in failing, you can't distinguish between them, because the speaker can't represent all of the tones in that range, or all of the inflections and the different frequencies of your voice going up and down, or the normal human voice. So frequency response is a big thing. STIPA, and these are just basically frequencies of a speaker and the acoustic, basically the performance of a speaker. So there'll be a performance of a speaker and its rating, and this is a little overboard, but if you just realize, or you say to yourself that I'm using a frequency, a speaker with a wide frequency response, a high fidelity. So in our world, in the Eaton world, all of our speakers on our legacy products, which weren't high fidelity, have been recreated in a high fidelity version. So you don't really need to know, I don't really need to go through the STIPO or the M&S FA requirements to produce the tones, just to tell you that they're high frequency, they're basically high powered, not high powered, but high fidelity speakers that have a broad frequency response for, like, say, from 300 to 8,000 cycles. That's what you're really looking to hear. Intelligible design, I told you, has a lot to do with the building. So very important to know what the building's made out of. So if it's new construction, it's a lot easier to look at your plans and let the team know that's doing the design, you know, what you're working with when it comes to walls and floors. You know, doing an intelligible design in an existing location, same thing. Have to know what's in there. You have to know the walls, what the floors are made out of, what's on the ceiling, you know, is there carpeting? Are they polished? You know, is there machinery in the area? What is that ambient level of audibility? Before, you know, you need to know that ambient level, where it is currently, where it needs to be as you design and come up with an approach for designing for the intelligible portion of the design. I'm sorry, I'm backwards. Designing outdoors. Doing good on time? Yeah. Same situation. The parameters are very important. The same principles apply. When we're talking about intelligibility, now in reality, the products that we sell or manufacture have intelligibility specifications right on it, saying, hey, this product is going to be on the intelligibility scale at 100 dB, at 100 feet. It's going to output with this particular speaker. It's going to output 123 dB at 100 feet and on the intelligibility scale of 0.8. So all this will be known in the cut sheets and the spec sheets. But if you're going to be using sound modeling software, it's important to know that all of these things that we're talking about here, wind, temperature, humidity, obviously the environment, what growth is around, the topography of the campus, how high the speaker is, all is going to play an effect in designing an outdoor system. It could be as complicated as everything I just said, or it could be as, you know, hey, I know the specifications of the speaker, I know what it can do, I'm going to design this system and then operate it under its performance value so I can get into the parameter I need. That's a very, very interesting take on designing for exterior. But again, designing for intelligibility outdoors, same as indoors, it's all done with sound modeling. It's mathematical. There are maps and parameters that need to be determined, and the design needs to be aware of all of it as you move forward. There's a couple of slides in here talking about our audio system. So an audio system for exterior design, and this is actually pretty important. An advanced speaker versus a traditional speaker. This will also have a great deal to do with a design where you need to be more intelligible in an exterior solution, whereas a traditional speaker system will broadcast in a way where it's targeting, you know, the speakers are all pointed outward. This is a very common system by just directing sound outward. These systems are traditional speaker systems. If it needs to be louder, let's say a traditional speaker system might be at a baseball, you know, at some type of sporting event, a field. A traditional audio system is a general system that's going to produce audio in all directions. You need more sound. You're going to get bigger amplifiers and more speakers and put them up. These type of systems tend to cause distortion and issues when it comes to speakers. That's why, you know, years ago when you'd go to a sporting event, the sound was much different than it is today because the speaker systems are newer. The systems are designed better, reflections and distortion, all of this stuff, sound deviation, the distance, the digital manipulation of the sound over a distance is all calculated. But in a traditional audio system, this is very common. This is a standard fire speaker. It could be just producing audio in a willy-nilly direction where it's just sending audio out. That's the nature of a speaker. When it comes to advanced speaker design, you're designing in a wide area environment. That's what we're actually talking about. We're talking about advanced design when it comes to intelligibility. This is an actual example of what our speaker array is, where it's a vertical line array, where the intelligibility is equalized, the power and the drivers are all balanced. Everything is designed in a way that the audio is far more directed. The speakers, it all has to do with the way it's producing its audio and how the drivers are reacting with the amplifiers. So just know that there's a difference between an advanced speaker design and a traditional speaker design. And the reason there is an advanced speaker design is because it needs to meet intelligibility requirements. Testing. This is just, kind of a checklist before testing for intelligibility. Make sure that your audibility is achieved. This is the volume. I'm talking to you louder. That's, as my voice increases, I'm talking to you about audibility. The intelligibility would be that maybe the microphone or the speakers that you are listening to can't reproduce the voice that my microphone has or my headset. So these are just some tests that they look for before running intelligibility tests that you look at. The audibility is reached. The audio system is balanced. The amplifiers are balanced and calibrated, that their gain is united in the amplifiers. It's quiet. There aren't things that are going to affect the sound or the modeling as they do the testing. That most of it, like the construction is done, is a big one. They're going to come in at the end of this, before the certificate of occupancy is issued, and run these intelligibility parameter tests. So we've got about 15 minutes, and I'm going to tell you right now, the next group of slides, this is all on code. I don't really know if we want to go through all this code, but this is going to go through, every edition, everything, and spell out, exactly what's in the annex on all these different groups. So right now we're starting with the NFPA 72 and the intelligibility guidelines, and this is going to go through all of it. This is, again, talking about design. Hold on a second. Let me see if I can jump around for a sec. Yeah. This is just going to talk about some design aspects of intelligibility. And this is actually good. I'm going to bring this up. Everyone's seeing this, I hope. These are important things to know. So the guideline of this specific spec that they're talking about, Fire Protection Research Foundation, these are things, there might be other methods of designing for it with using, all these different measurements and specifications, the occupancy, the finishes that I've already told you. So when it comes to doing the design, most of it's done by modeling software, and all this information really needs to be known. When a customer of mine or a customer, like somebody perhaps that's on the phone gives me a call and says, hey, I've got to do this design, I usually set the expectations of what I need, what we're going to need, what are you using, do you have the drawings and so forth, so that we can hand it off to someone that will use the modeling software. But these are just some guidelines that are related to intelligibility, the design, and what's known as ADS, or acoustically distinguishable spaces. That's another buzzword in the intelligibility world, meaning that the system needs to be designed. I'm saying now, it's the first time you heard me say ADS, but talking about intelligible design, you're talking about what they call in the spec an acoustically distinguishable space, or an ADS. And in the world of designing for intelligibility, you're talking about all those characteristics and all those things I mentioned earlier. The stairwells, the floors, the walls, the windows, the material of the wall, the material of the floor, polished surfaces. That's all that they're talking about. The furniture, what's in the room. There's air walls, or there's low air walls, or, you know, cubes and all that. That's where they're talking about the acoustically distinguishable space within the intelligibility. And again, each time they're going to come up with variances on the chapter and of intelligibility and the chapter of NFPA and with their guidelines. And, you know, I'm not going to go all through this. This is just telling you that they changed from 24 to 18. And again, talking about different areas that require the codes and the standards, and, you know, whether it's a bathroom or an elevator. A lot of times bathrooms, stairwells, storage rooms, specifically closets, all these areas are discussed in more detail in the code, or where they are and where they're not required. The 520 hertz, or the low frequency sounder, is something I mentioned earlier. That 520 hertz is pretty low. It's a pretty low tone. This is a new code in NFPA. Having a speaker that can play 520 hertz is important. If it's above the frequency response, it's going to be a distorted, clipped sound. Not going to be able to hear it. And they're just going to continue. We're going to just continue going through requirements right out of the code book. These are all right out of the code book in the different editions and chapters. I don't think this is really, for this discussion, really worth it. Let me see if we can jump forward, and before I maybe want to hand this over. Yeah, this is all code driven. And then here's the annexes. I'm sorry if I'm rushing through this. Yeah, we're just gonna hop over here, and Mike, you there?
I am.
Okay. Yeah, you know, we got about 10 minutes. I don't think it's really important to go through all the code. It's about 15 to 20 slides just in code that we're going to call out. I think maybe it'd be better to go through the questions. You wanted to hand it off to...
Well, AJ will not be joining us, so here's what I'd like to say. If you all have questions, please put them in the Q&A box, and we'll hang out, and I will get Robert to answer all the questions that come in. If you all have a need for these products, let's try to get you engaged with the Eaton Wheelock team, so that we can all try to win on these mass notification opportunities. So we'll wait.
And that's really well put, Mike.
We'll wait a minute or two and see if we get some questions, and we'll go from there.
Yeah, and as you guys are thinking about it or sharing them, again, I like to press upon a few things. Again, this course is designed, there's not a series of slides that put us up on a soapbox talking about our product. It's just habit that I do. This is designed more for just educating the person. When it comes to intelligibility, use your resources. You know, pick up the phone, get a sales manager on the phone, and bring them in on it. And they'll educate you in this case. They'll be like, listen, you know, what are you using? This is what we offer. If you're interested in using our product, we can put you up with, put you in touch with our design team in New Jersey, and run through the drawings with you, and run through different sound models related to the spec. This happens in my world all the time. Most recently, something that you're going to get involved with, something that's completely out of your scope, like someone coming and saying, hey, I've got a military customer that's putting in a system in a hangar, and I've got to meet these requirements. So you get the drawings, you go through the drawings, you start looking at everything, and you say to yourself, this is completely out of my scope. We hand it over to the design team and set up a call, and you start running through models, and you say, listen, you could use this or this, and you could attain this. And this most recently happened to me in this exact scenario, where the customer and the spec are calling for a specific intelligibility, which can't be met. I mean, they took it to other manufacturers. It was just unattainable. But you have to go through these various scenarios. Use your resources. Bring people in that know what they're doing, that know their product, that understand intelligibility, that understand that all that ADS, all those pieces of the puzzle fit and affect the overall intelligibility of that project. Use your resources. That's exactly what I do. You know, call somebody to help you out when it comes to this. It's like, hey, I don't know what I need. You know, is there a hi-fi speaker? You know, ask, Mark Ingram in the Northeast, or myself in the Mid-Atlantic, or, one of the guys out West, or whoever. Just pick up the phone and use your resources. Critical.